It was early 1950s. Eugene Osirinsky, a graduate student at University of Chicago, put his 8-year-old son to bed as usual. That evening, he attached a few electrodes to his son's head to monitor brain activity of that little boy during sleep. To his surprise, he observed intense electric activities in brain, even though his son appeared to be in deep sleep. This discovery revealed a crucial aspect of our sleep patterns, making them instant celebrities. This finding led to the identification of REM sleep, a critical sleep phase linked to dreaming. Osirinsky's research, in collaboration with his advisor Nathaniel Klitman, transformed our understanding of sleep and its various stages. If you are in search of good quality sleep or wish to know how sleep helps in sharpening your memory and immunity, this article will just be for you. Many patients in our clinic experience sleep problems. To achieve good sleep, it is essential to understand the history and science of sleep. This is the second part of our sleep series. In the first part, we explored the fascinating scientific history of night sleep and afternoon nap. Today, we delve into the current science of sleep. In the next and final part, we'll discuss the trigger of sleep. But first, tell me one thing. Is it better to stay awake and study or sleep the night before an exam? The answer may surprise you. Body's electrical activities. Let's start with some basics. What exactly happens in human body? Mild electrical activity is constantly sweeping all over human body. Let me give you an example. Understanding how the heart beats may help you understand the electric flows of the brain. Heart beats with the shock of mild electrical activities that flows inside heart chambers. We check heart's electrical activities using electrocardiogram or ECG, a household name. We must use ECG to check if our heart is functioning properly. Similarly, we can measure brain's electrical activities. Electroencephalogram or EEG measures brain's activities. By placing the device on the head, we can observe the brain's workings. When awake or excited, the brain's electrical activity increases, which is expected. However, by using EEG machine on sleeping individuals, scientists found out our brain is intensely active even during sleep. Exactly what Eugene Osirinsky discovered on his son's head. So, was the machine wrong? Not at all. It is now known that our brain works at full speed even while sleeping. Brain activity at certain times during night can be much greater than at some times during day. Fascinating, isn't it? Moldovan mad scientist Nathaniel Klitman and his even more mad American student Eugene Osirinsky spent countless nights studying sleeping individuals. By 1930, Dr. Nathaniel Klitman enlightened us about the rhythm between sleep and wakefulness. He discovered that if the rhythm is disturbed or if proper sleep is lacking, the physiological processes of the human body gets all hindered. Mental alertness becomes dull. Tragically and rather paradoxically, Eugene died in a road accident having fallen asleep at the wheel due to exhaustion from his relentless sleeping work. The brain clock. 10 years after Klitman and Osirinsky's research, Swiss researchers Walter Hess discovered that a small organ called thalamus located in brain center balances our sleep and wakefulness. A decade later, in 1950s, scientist duo Kramer and Hoffman brought to us an invisible clock in the human body. Circadian clock, from Latin circa means approximately and diem means day. This groundbreaking study revealed how our bodies and minds follow a certain rhythm day after day, year after year, century after century, even without a clock on the wall. Even without a visible clock, we fall asleep at the same time each day. Our body's hormones and cycles, including a woman's menstrual cycle, follow this invisible clock. Such day and night rhythm was perhaps first discovered in plants. In 1729, French astronomer Jean-Jacques Jotu de Mero conducted an experiment with mimosa plants. He observed that the plant's leaves opened during the day and closed during the nights, even when the plant was kept in total darkness for 24 hours. Initially, science was skeptical about this internal clock. However, over the next 15 to 20 years, French and German scientists conducted extensive research in complete darkness, confirming the existence of this sleep clock. Our body and mind operate under the precise instruction of this sleep clock. Just as faulty wall clock disrupts daily activities, a disrupted biological clock in our brain affects physiological processes and harms our health. The story doesn't end here. EEG experiments have provided more fascinating insights into sleep. Interested? Be patient, as this can be a little bit complex. Research has shown that EEG lines broadly divide our brain's electrical activity during sleep into two parts: REM sleep and non-REM sleep. One non-REM and one REM sleep together forms sleep cycle, lasting approximately 1 to 2 hours. Several sleep cycles make up full night sleep. Waking up in the middle of a sleep cycle leaves you tired, while waking up at the end of the cycle leaves you refreshed. Set your alarm in multiples of 90 minutes, such as 6 hours or 7.5 hours, like that. In the first part of the sleep series, we discussed whether afternoon sleep is beneficial and how it differs from night's sleep. Afternoon sleep alarm should be set just before the end of 30 minutes nap, just so that you can avoid entering into this REM non-REM cycle in the daylight. Sleep begins with non-REM, that is non-rapid eye movement sleep, which has got 3 stages. Electrical discharges vary in different body parts. During this time, we might babble or grind our teeth in sleep, and some may wet the bed. Next is REM, or rapid eye movement sleep, where our closed eyes move rapidly and we dream. The muscles of our limbs becomes completely relaxed to prevent us from acting out in our dream. If you compare the rhythm of brain activity during sleep to drumming, we see that sometimes all brain parts are highly active. Most of the time, this activity is fast and rhythmic, followed by a few minutes of strong but slow drumming. This slow beat sleep sharpens our memory. Then the fast rhythm returns. The sleep memory link. Imagine the information in our head as a library of books. Past memories are neatly lined up on a bookcase, while new memories are placed randomly on a table in front of librarian by the door. According to library rule, if these haphazardly placed books are not shelved, the housekeeping staff will discard them the next day. Meanwhile, our librarian can only work when the drum sound is very slow. The quieter and the slower the drum sound, the more books our librarian can arrange into the shelves. Tireless work and meticulous sorting occurs in our brains, even when we think we are sleeping. During sleep, there is a brief but specific opportunity to organize our immediate daily memories with past memories. If sleep is insufficient or stress is present, this slow beat sleep process is disrupted or shortened. Consequently, our ability to remember new information diminishes. Adequate sleep is crucial during exams. Without it, memory can be unreliable. It does not end here. Our brain and spinal cord float in cerebrospinal fluid. During slow beat sleep, nerve cells bathe in this fluid, removing harmful chemicals and cleansing the brain. What a tragedy if this process is hindered. In neurological diseases like dementia or Alzheimer's, the librarian's work becomes so limited that new books cannot be shelved, and the old books gradually start to disappear from the shelves. Recent memories fade very fast. Old memories takes a little bit time to disappear, while very old memories last longer. In some neuroses, individuals remember distant past events but struggle with recent information such as names of new friends. Research repeatedly shows that lack of sleep increases the risk of blood pressure problems, stress, diabetes, heart failure, cancer, and obesity. A Surrey University study on night workers in the London Underground found out that disrupted sleep increases cancer risk. The effects of poor sleep reduces our immunity. Even at the microscopic level, lack of sleep can disrupt the gene expression. Don't be alarmed, but be aware of the importance of the sleep. If you can get 6 to 7 hours of sleep a night, take advantage of it. Don't fall for the myth that you can function well on minimal sleep like Margaret Thatcher or something like that. Avoid saying you can't sleep because of what late night or watching web series. It might be manageable for a day or two, but not for months on end. If you do not give proper respect to sleep, sleep will take its revenge one day, for sure. That was almost the end of the second part. Some can sleep well, but others find it difficult to sleep. For them, I am coming up with our third and final part of this sleep series, how to master the triggers of sleep, so that you can have a dream sleep. See you soon.